Hi, again, my name is ChangHun, and I'm a developer of the Supertone, the AI voice tech company. I'm happy to announce my new visual programming language for AI researchers and audio developers. It is very first premiere of this project, so I'd like to say it is a great honor to have a great opportunity in this ADC 23. So let's start. First I'd like to talk about the pipeline of the product development that I experienced while working as a software engineer at an AI tech company. At the very beginning of pipeline, our research scientists do some magic or research and training models. The models are then tested, optimized, and exported in a form that can be put into software. This is once again wrapped in an intermediate medium in the form of such as a SDK or toolkit, which is then built once again as a plugin or other end product. Finally, it goes through the tedious QA process and is finally get released. But as a developer of myself, I'm involved in most of these pipelines, except for the AI training things. In an ideal world, this long process would be seamlessly flow, but the reality is usually far from that. With all of these dependencies, and there's always a chance to something go very wrong. And then it all turns into a developer's work. So, of course, as a programmer, it's my job to write a code, but as we all know, writing a code efficiently is more important than writing a lot of code. Writing less code is more important than writing efficiently, but the best thing is not to code completely. So I decide not to code in old-fashioned way anymore. So now I'm introducing a new development framework named Node. Node is a node-based visual programming tool. It integrates inference engines such as PyTorch and Onyx Runtime and TF-Lite. It also supports direct connections to audio and MIDI devices. It's performance-oriented architecture, which is close to, and in some cases faster than native C++. The modular design also allows programs that developed in Node to be easily reused. And also, Node accelerates the development process. AI researchers still do their job outside of Node, but the AI models they created can be uploaded directly into Node. Profiling, experimenting, and parameter design, and even quality assurance can all be done through Node's many features. When they are done, all we have to do is put some UI code and release it. So here's some of the products we've been working on. The first is the voice separator plugin, which we just released last week. Let's take a listen to the demo first. Okay. Oh, it should be. Sorry.
I'm from Niagara Falls, Buffalo, New York area, and I'm sitting at Union Street Station in Denver for a class called Jack Kerouac, something along those lines. It's a really long name. Well, I actually hitchhiked from...
You can hear that it clearly separates the voice from the reverb and noise. On the right side is the Node graph that we use to develop Clear. Let's quickly move on to the next one, Project Shift, a real-time voice conversion plugin that converts your voice into another ones with very low latency. It is not released officially yet, but it is also developed using Node, as you can see here. We'll see the demo at the end of the presentation, so please stay tuned. This time we are going to dive a little deeper and give you a quick overview of how Node works under the hood. It is designed to adhere to two main underlying theories. One is Turing completeness, and other is the functional programming concept. As many people already know, Turing completeness is a requirement for a system to be programmable. In general, a system is said to be Turing complete if it can implement the variable declarations or conditional statements or loop and subroutines. By designing Node to be Turing complete, we can implement much more flexible algorithm with a few elementary nodes. And functional programming is a theory of computation based on lambda calculus, which is also the basis for many functional languages. All functions are pure functions, and programming is done by creating new functions through the decomposition of multiple pure functions. Because every specification of input and output has already been defined precisely, DSP fits well with the functional programming. And we'll start by introducing the type system of the node. A unique feature of Node is that while it is a system for dealing with audio, but the types are designed to deal with lower level types. This is broken into components called parameters and properties. Let's say we have this function. So the parameters of this function consist of input parameters ABC and output parameters XY, while the properties define the certain specification of these parameters. For example, it defines which parameter comes in which type or size or somehow range. We might also express function like this way. And properties are used to determine whether a node can be connected to another node. Only things with the same property can be connected, and parameters of different properties are not allowed to be connected. Next, the feedback connection. In general, processing is like executing functions sequentially. However, some processing requires that the result of the previous processing be used as an input to the current processing. In Node, we use a dashed line to represent feedback connections. This allows us to express referencing from previous results without breaking the execution order of the graph. This also allows us to express stateful processing logic using only a combination of pure functions. We'll show an example a little bit later. Some of the conditions in Turing-complete system include loops and conditional statements. I try to keep a perspective of node. For example, let's say you have a node that takes in a tensor with 512 columns, while output is a one-column vector. In order to take a single input and output multiple times, these nodes will inevitably have a context inside them, which means they can never be expressed as a pure function, and vice versa. So I've named them a loop open and loop close node. And this way, you can cluster the intersection of the child nodes and loop open and the parent nodes of the child close like this. Although both open and close must be same number of iterations to be valid, but this is called loop clustering. So again, when you run this graph, this inner cluster will be repeated in a certain amount of number times, but externally, you can treat this cluster as a pure function. And next up is branching. Branching is a little bit easier than looping. It's like a ternary operator in traditional programming language. We first evaluate the condition value, which is a single Boolean type. As you can see, the white color is Boolean type. And if we first evaluate the condition value, if the condition is true, the top input passed to the output. And if the condition is false, then bottom input is passed to the output. We can do some optimization during branching. So the nodes connected to the branching nodes can cluster like this. The upper one is the condition cluster, and second one is true and false clusters. As you can see, the leftmost node, it can't belong to either cluster because it affects both the true cluster and false cluster values simultaneously. So in the same way, branch cluster can be treated externally as a single pure function. When you run this function, internally it will run the condition cluster first, and then only run one of the two clusters based on the results of the condition cluster. There are a lot of very interesting applications that can be created using this composition of the branch, but for the sake of time, I'll leave them out of the presentation. And here comes the most fun part, memory scheduling. I've been applied a variety of C++ optimization techniques that I know as much as possible, but this is the one thing that I would like to introduce. Once the graph is determined by the connection between each node, the connections never change at runtime. So this allows us to statically analyze the memory space required to run the graph. In a simple calculation, there is 12 inputs in here and 10 outputs, so it requires this this number of memory, technically, but since the entire graph structure is static and rigid during the runtime, so static garbage collection can be done. Because every order and size of memories are already been defined by some methods such as reference counting or in-place processing, we can pre-calculate the optimal memory size that needed to execute a function sequence. It will reducing most of memory-related overhead. On top of that, if each function has determined which areas to read and which areas to write when performing their behavior, we can remove the input and output like this. So it can be converted into the void function that actually has no input and no output at all. Again, all functions know where to read and where to write by itself. So all we need to do is execute these converted void functions just in the right order. So the actual graph execution logic for node ends up looking like this, just calling a void function pointer sequentially. Isn't it beautiful? So to summarize, here's what the node compiler does. It takes a graph from the user and detects loop and branching cluster to make it as a pure functions, then optimize memory space and pulls out the function sequence at the end. Now, I'm going to show the process how we created a clear plugin step by step. Let's go next. Okay, first load the AI model created by our research team. So the name looks like scientific. And AI model can be either an ONNX file or a torch script file. For this model, we'll connect the hidden state layer and last state layer from the previous output. So the feedback connection making a stateful data transfer, because we'll need them for the next processing to calculate some kind of that output. Next, attach the pre-processing and post-processing to the front and back of the model. This process can be somehow complicated depending on how your AI model is implemented. But even if your logic is quite complex, as long as you modularize it into something like this below, then user won't have much to worry about how to use this model, just connecting this node into their desired another node. However, there's one problem with using it right away. So as you can see, that number is the size of the buffer. The input-output buffer size of the connected audio device is 512, but the clear model receives 384 samples as an input. I don't know where does that number came from, but yeah, but we don't have to blame scientists, because just adding a dynamic ring buffer to clear module before and after, like this, the dynamic write and dynamic read is a kind of ring buffer that receives and emits the dynamic number of the output. So then the loop cluster will be created for this module, like this, here, the loop cluster. Then it will run like a ring buffers are attached in front and the back side of the model. One more thing. Clear also comes with the toggle switch to select a more lightweight version of the model. You can see the echo mode button here. So users should also be able to choose which model they want to use. To do this, we'll utilize the branching feature. A bool variable node here will act as a toggle switch. If the switch is true, then the true cluster on top the echo model and will run top of that cluster. And if the condition is false, which is toggle switched off, then the bottom side, the more accurate model will be run. So this is it. We just create a clear plugin from scratch. You can export this graph as a plugin such as VST, AU, or other plugins format. Now, let's try some live demo. Please don't crash. Previously said, Shift is our real-time voice conversion software which has a very small amount of latency. And this time, let's take our two real-time AI plugins and combine them into one. So what do you think we can create? First, this is how Shift looks like. Shift needs have to put 10 seconds of source voices to make seamless blending to target voice. We call it voice enrollment. So we will use clear to input a clear voice into the shift, while other components such as noise and reverb goes directly to the output. Let's see how it goes. Okay. So here's the node. Let's load clear shift. So I basically do some previous work. You can see the voice clear attached like this. It receives 3 gain sliders like this. So it controls the voice dry gain and voice wet gain, and then ambience gain. Sorry for the UI glitch, but it outputs the each voice dry, voice wet, and ambience here. So I disconnect. Before I disconnect, let's try. If I turn every slider to 1, then it is same with the bypass.
When I graduated in the early 1990s, I went on a trip around the world with a few good friends who actually remain good friends to
If
this
I
day.
reduce the voice and outside the ambience here, and let's hear the sound. So if I increase the voice dry
And the
part here,
brightest. You have great potential and possibilities.
and the voice wet.
Therefore,
So this is how
you
a clear
have
works.
enormous responsibility too.
Thanks, Justin. And disconnect all the outputs. So let's add a shift here. Shift. Here comes the shift. So I put the clear voice directly into the shift, while just put the rest of voice into the output directly, like this. Oh, yeah. And there are 3 Boolean type parameters here and 3 integer type parameters here. You can see it like this. Okay. The one thing is bypass, as the classical bypass, and start enrollment, and the flag that output whether the enrollment is complete or not, and the reset flag. And the speaker index is literally the index of the speaker, and the blend is how much do you want to blend into the target voice from the source voice, and the pitch is the relative pitch parameter. So let's try the demo here. We have 3 Boolean value here, so copy paste, align left, stack vertically, and connect them at once like this, and start enrollment. And we also have a value scope to see the enrollment is done or not. And we have int slider value over here, 3 int slider. Align left, stack vertically. And then connect them at once. So let's start from the beginning.
So today, I'd like to talk about the nature
As I said before, the shift needs 10 seconds of the video to convert this source voice into the target voice. So I'll press the start enroll and waiting for 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the enrollment is done. Once the enrollment is done, I'll put the blend parameters from here. Oops. This, okay. Hey, please. What happened here? What happened here, please? It's supposed to be work. Let me try it once. Okay.
We trekked and traveled most au sens plus large du terme, parce que j'ai dû, pour la première fois en tant qu'adulte,
Enrollment
rencontrer,
is done
échanger et
in
tisser des liens
seconds.
d'amitié
Okay,
avec
true.
des gens qui
Okay, let's
partageaient
blend
pas
the
toujours mes
voice
opinions,
into
mes expériences, mes idées, mes
100%.
valeurs.
Ouh là là.
Okay, so speaker index number 0 is a young woman's
Also,
voice, but
an
guess
a
whose
really
voice is?
important contributor to my
Continued broader education because it forced me, really for the
While
first time
the
as an
converting
adult,
voice, you
to
can
meet,
also
engage,
directly
befriend
feed the
people
ambient
whose
noise
views and
into the output.
experiences,
So seamlessly,
ideas, values,
it
and
just
language
convert the
were
only
very
voice,
different from my own.
or
See,
maybe
when a
we
kid
can
from
test.
Montreal meets a Korean fisherman living
This
in
sound
Mauritania.
was designed to be
Befriends
mimic
a
a
Russian
alien
veteran
voice,
of
I guess.
their Afghan war,
Another one
or
is maybe
shopkeeper in his
number 2.
family living in Danang.
Interesting conversations
Yeah.
always happen.
It's amazing, quite amazing, right?
Now,
And
maybe some
after
of you have
that,
talked
if we
about
want to
doing
build as a
something like a
plugin,
great
then
trip like that
export
after
as a package,
graduation.
then it
But I'd
comes
be willing
as
to
a
bet
VS
one of the
plugins
first
or
things you
audio unit
heard
plugin at
was a
once.
warning.
But I'm not going to show
Can't
the
do that
demo
in this
because of the
day and
time.
age. It's nuts.
So thank you. Thank you very much. Sorry. It's not the end of the demo, but thank you for your applause. So let's move on to the first image I showed you at the beginning. We didn't cover everything here, but the process of developing a product with an AI model is much more complex than it used to be. So now it aims to simplify this process as much as possible, and we are working on many features and extensions to accomplish this. There are a variety of further tasks to be done. Of course, there will be more optimizing tasks, such as, well, more optimizing the compilation time or running task time, and multi-thread graphic processing to distribute the processing task into multiple thread pools. So if there is some kind of heavy AI models to be inferenced in the background thread, then let that model runs in the background thread while the real-time thread runs the audio rendering in real time. And supporting various platforms such as Python bindings, web audio bindings, and integrates with the ARA or CLAB, etc. And of course, user-oriented features such as step-by-step debugger, because this is a development tool, and variety of the user input interfaces, such as a lot of knobs and sliders, and testing environments for the quality assurance features. So for the closing, I'd like to announce the information that I'm sure everyone is here curious about. Now the plans to release a beta version to the audio developer community next year, March. So please stay tuned until then. Thank you.
I'm curious, did you use any libraries for building the GUI for this, or did you build that all from scratch today?
Actually, I built from scratch the compiler, but I utilized the GIS framework to build the UI things.
Cool, thanks.
We have one online question. Is this a macOS only framework or also available on Windows?
Oh, it is available for every cross-platform because it is built with the native C++, which is a highly cross-platform friendly language. So yeah, it can be run on the Windows also.
Perfect. Thank you very much. There's also some words of appreciation. That's incredible work. Any other questions? Yeah, please. Right. Okay, sorry.
So what's each module, what is that written in? Is that C++ or?
Yeah, every modules are written in C++, but you can write your own modules with the Node. So basically the Node graph is the XML format. I'll show you the example. It's simply XML format file. So you can write your own nodes, your modules within Node, and export it and distribute to the community as a node. Am I understanding right?
Yeah, it was just like when you then write a node or the actual code that does the processing, is that done in C++ then? Yeah, okay, thanks.
And also I utilize SIMD as much as possible to accelerate the performance. Yeah.
So you said you can export this into plugin formats like VST3. Could you? I'm not sure if I missed this. Could you explain a bit? How do you put a GUI on top of that? Are you getting some C++ code out that you make your own, or how do you actually connect?
Actually, I built another plugin that implements the Node compiler inside. So the plugin can load this kind of XML graph into that plugin. So just run the graph file in that plugin. So, yeah.
Perfect. Do we have any other questions?
Yeah, thank you for the talk. Which format will this be released? Like open source, free software, or licenses?
It's to be decision, but I will release the editor to the public. But I'm not sure I'm gonna entire source code to the open source, not really, because the projects belongs to the company. So,
But free?
Maybe for free, yes. Because nobody nobody owns their programming language into the company. Yeah.
Yes, are there any more questions here? We have one online question also. So I'm gonna read it. Somebody's asking how the UI is built, vector shaders, images, what is possible?
I'm sorry, can you read it?
It says, how is the UI built, vector shaders, images, what is possible?
Oh, actually, I implement the OpenGL shader to show some. I can show you the graph, the type of audio here. So this is basically OpenGL renderer. It shows the spectrum like this. Yeah. So I use native C++ to rendering such things. And also, it can treat a tensor type, so it can also be implementing a image processing logic as well, I guess.
Perfect, thank you very much. Any other questions from the audience? Okay, well then, I guess I have one. You mentioned the plan of including a debugger for this tool, which is probably something rare for a visual programming language, and I'm wondering if you have UX ideas for us, like how are you imagining implementing it?
Well, I have a really rare idea of how to implement the visual debugging things. Just as you can see, this is all of debugger features in this for so far. So falls through, or you can see the scope.
Print debugging, like yeah, let's start with the basics. That's good.
If I implement some kind of step-by-step debuggers, then you can profiling a memory inside the graphs. So it could be helpful to debugging, but yeah, it depends on.
I guess we're out of time anyway. So please give a big hand to the speaker again. Thank you very much.